This is Dr.S.Selvalakshmi, Assistant Professor of Physics, the Standard 5 Works Rajaratnam College for Women, Sivakasi. In this video, we are going to learn about the advantages and working mechanism of phosphoric acid fuel cell. Learning objectives. On seeing this video, you will be able to know the history of phosphoric acid fuel cell, describe the working principle of phosphoric acid fuel cell, analyze the limitations of phosphoric acid fuel cell, and identify the applications of phosphoric acid fuel cell. Let us now see the history of phosphoric acid fuel cell. Phosphoric acid fuel cell is considered as the first generation fuel cell. It was invented by G.V. Elmore and H.A. Tanner in 1961. Phosphoric acid fuel cell has various components. It has two electrodes, a negative electrode and a positive electrode, and an electrolyte in between the electrodes, and a catalyst to speed up the reactions, which is platinum. So here the electrolyte used is concentrated phosphoric acid, and the negative electrode is nickel, the positive electrode is silver, and the catalyst used is platinum. Let us now see the functioning of a phosphoric acid fuel cell. Here the phosphoric acid fuel cell, pure hydrogen is supplied at the negative electrode and oxygen is supplied at the positive electrode. Platinum serves as the best catalyst for both electrodes. At the negative electrode, hydrogen gas is converted to 2 protons and 2 electrons. The electrons originating at negative electrode flow through the external load to the positive electrode. Also, protons migrate from negative electrode towards the positive electrode through the electrolyte. On reaching the positive electrode, they interact with oxygen to produce water. This slide gives the electrode reactions of phosphoric acid fuel cell. At the anode, hydrogen molecule is split up by platinum into 2 protons and 2 electrons. And at the cathode, the protons which migrate through the electrolyte reaches the cathode, and 2 electrons which passes through the outer load reaches the cathode and reacts with the oxygen molecule to produce water. So the overall reaction can be mentioned as half oxygen molecule reacts with hydrogen molecule to give water. This is the overall reaction of phosphoric acid fuel cell. And now let us see the characteristics and performance of the phosphoric acid fuel cell. The operating temperature of phosphoric acid fuel cell is 150 degrees Celsius to 200 degrees Celsius. At atmospheric pressure, it produces an ideal EMF of 1.23 volts at 25 degrees Celsius. Normally, the rated values of current, the voltage lies between 0.7 volts to 0.8 volts. Now let us see the applications of phosphoric acid fuel cells. Phosphoric acid fuel cells have been used for stationary power generators with output in the 100 kilowatts to 400 kilowatts range, and also finding applications in large vehicles such as buses. India's DRDO has developed PAFC based air independent propulsion for integration into their cavalry class submarines. The PFC were used as power sources in military purposes in US. Let us now see the limitations of phosphoric acid fuel cell. The electrolyte solidifies around 40 degrees Celsius. So the battery must be kept at a higher temperature to avoid damaging the electrodes. The strong corrosivity of the acid causes deterioration of the electrodes. It is also sensitive to sulfur. High cost of the catalyst is also a limitation of PAFC. So let us meet in the next video. Thank you.